Hi, this is Mrs. Robertson, and today we're going to learn about percent of change in my Math 7 cluster class. We're going to start by looking at the inquiry lab located in your math book on page 141. All right, we're not going to do all of the questions here in this, but I want to just look at how they do their tape diagrams or bar diagrams. Here we have a problem. It says the admission price for the State's Fair has increased by 50% in the last 5 years. The admission price was $6 5 years ago. What is the current admission price? Do the activity below to find out. So here we have the bar diagram. It represents 100%. So that 100% 5 years ago is $6. Since 50% is half, divide the bar diagram in half, okay? So we cut it in half. So this piece is $3, this piece is $3. 5 years ago, it was 6. So let's put a 6 in there. What was the price 5 years ago? 6. Now, we're going to go on to step number 2. Any questions on what they did in step 1? Okay, we're ready to look at step 2. In step 2, it says the admission price increased by 50%. Complete the bar diagram that represents 150% of the price 5 years ago. 100% means it's the same amount. So 100% of $6 is $6. So it's that much plus 50% more. 50% of $6 is going to be another 3. So you have the current price, our 5 years ago price of 6, plus the 50% increase of 3 equals $9. So the price would be $9. 5 years ago, that's 100% plus 50% equals 150%. So 6 plus 3 equals 9. Any questions on that? Now let me just move it up here a little more for you so you can see 6 plus 3 equals 9. Let's go to page 142. We have another problem to look at. We're not going to have time to work with a partner on these, but we're going to look at problem number 1. The height of a tree is 8 feet. After a year, the tree's height increased by 25%. Draw a bar diagram to find the new height of the tree. So we're going to draw a bar diagram. So this is going to equal, I'm going to say this is 100%. Okay, so we have the first part, and it had grown 8 feet. So this represents 8 feet from here to here. Okay. The tree's height increased by 25%. 25% is what fraction, class? 1/4. So you're going to cut this box up into 4 pieces. Okay, let me switch colors. So, and when you cut it up into 4 pieces, what's 8 divided by 4? So there's a 2 in each piece. And then we're going to increase the box by 25%, which will be another 2. So the total amount will be 10 feet. We're going to do problem number 2, and then we're going to go into our percent of change lesson. It says the model below describes the following scenario. Ryan put $160 in a bank account. Okay, there it is. After 2 months, the total in his account decreased. Decrease means it goes down by 25%. Fill in the amount in Ryan's account after 2 months. Well, 160 is 100%. It decreased 25%. So that means it's 75%. 100% minus 25% is 75%. That's where they got the 75%. The amount in Ryan's account after 2 months is, well, you can take 0.25 times 100 or 0.75 times 100. If you do 0.7 times 100, it will give you the exact answer of 120. I think I should have said 0.75 times 160. That equals $120. If you multiplied 0.25, that's running out of ink, change percent to a decimal, times 160, you're going to get 40. Then you'll have 160 minus 40, because that's how much money they lost or decreased the account by. You would get 120 that way. Both ways will give you $120. Now let's go to page 143, and we're going to learn about percent of change. 143. It says the Indy 500 is one of the world's great motor races. The table shows the average speed of the winning race cars for various years. Okay, in 1922, 94 miles per hour. 1950, we're talking Model Ts back then. Okay, they're racing each other, that type of car. 1955, 128 miles per hour. 2010, 162. Do I have any race car enthusiasts? How fast were the race cars going the last couple of years? Do any of you watch the Indy 500?
200.
I was thinking it's over 200, isn't it now? Yeah, in the 2020s, they're over 200 miles. 20s over 200 miles per hour. We might want to look that up, but I know I've heard it's like, maybe they go that fast, but maybe the average speed. Is this the average speed? Speed.
They still average.
It might. We'll see. We'll have to look that up. I'm just curious. Okay, so step 1, write the ratio. Speed increase from 1922 to 1955 over the speed. Okay, write the ratio. So, excuse me, we're doing a recording. Let's be quiet. So in number 1, write the ratio as a percent. So we're going to have the difference is 35, 1920, or 34. In 1922, they would go 94. So the percent of change, you write it as a fraction, divide, you get 0.36. 0.36 equals 36%. The percent of change is 36%. Now let's look at the next one. The speed increase from 55 to 210. Again, it's 34. But we're comparing it to 1955. In 1955, it was 128. So we're going to divide. And when you divide, you get 0.27. And 0.27 is 27%. Everyone remembers, how do you change a decimal to a percent? You move it 2 places to the right. Okay. Why are the amounts of increase the same, but the percents different? Okay. The change is the same. Why are the amounts of increase the same, but the percents are different? What makes it different? We're comparing it to 2 different what? The denominators are different. 2 different original times here. We're comparing it here to 94 miles per hour. And in number 2, you're comparing it to 128 miles per hour. Now let's go to page 144. In page 144, question. I'm making a video. You can watch the video after we're done with this. I'll post it in the classroom so then you can see it. All right. In this problem here, a percent of change. might help it. The percent of change is a ratio that compares the change in quantity to the original amount. So you're changing the quantity to the original amount. 1 second. All right, a percent of change is a ratio that compares the change in quantity to the original amount. So it's really easy to remember this formula. Amount of change over the original amount. Okay? So let's go and do a couple problems. When you compare the amount of change to the original amount in a ratio, you are finding the percent of change. The percent of change is based on the original amount. If the original quantity is increased, then it is called a percent of increase. If the original quantity is decreased, then it's called a percent of decrease. Okay, so when it increases, amount of increase over the original amount will give you the percent of change. When the percent is a decrease, then you put the amount of decrease over the original amount, and then you will get the percent of decrease. Let's go now and look at example number 1. In example number 1, it states that, it looks like we're finding gas prices. Find the percent of change in the cost of gasoline from 1970 to 2010. Round to the nearest whole percent if necessary. All right, so step 1, we are comparing it, find the percent of change, to 1970's price. Okay, so find the amount of increase. $2.95 minus $1.30 is $1.65 is your increase. It did increase. Now you put it over the original amount. What are we comparing it to? 1970, which was $1.30. So you have $1.65 over $1.30 equals 1.27, which equals a 127% increase. So the price of gas in those 10 years went up 127%. Okay? Now let's go on to problem number 2. In problem number 2, it says Yusuf bought a DVD recorder for $280. Now it is on sale for $220. Find the percent of change in the price. Round to the nearest whole percent. Okay, is that going to be an increase or a decrease, kids? Decrease. So you're going to find a percent of decrease. So the amount of decrease, which is 60, over the original amount, which was 280. 60 over 280 is 0.21, which equals 21%. Okay, now I would like for you to do A and B. So do the problems, and then I will be right back. I'm going to put it on pause. I will just go ahead and do these with you. So what's the difference between 10 yards and 13? 3. So you're going to have 3 over the original, which is 10. 3 over 10 equals 3/10, which will be 30%. So the answer for A is on a 30%. Now, is it an increase or a decrease? Increase.
How do you know which one's your original?
It's the one that you start with. It's a good question. Let's do letter B. The price of a radio was $20. That's the original price. It is on sale for $15. What is the percent of change? Okay. Did it increase or decrease? This one's going to be a decrease. 20 minus 15 is 5. So you're going to have 5 over the original, which is 20. Okay, now I can just get that over 100. 20 times 5 is 100. 5 times 5 is 25. And 25 over 100 is 25%. It's a 25% decrease. Any questions? We're going to skip the part with the percent of error right now for today. And we're going to go to the guided practice on page 146. And I would like for you to do 1 and 2. We're not going to do number 3. So on this page, do 1 and 2, and then we'll talk about what your homework is going to be or it's classwork. It's Friday. We usually don't have much homework. If you work hard, you should get all the problems done that I want you to do. Okay. So we end up in number 1 getting a 20% decrease. How? The difference, 30 minus 24 is 6. What was the original? Number 2. Here, the difference, 150 minus 126. Now, the original is 126, and it went up. So it's 0.1904, so it's a 19% increase for that problem. A 19% increase. It went from 126 to 150. The difference, I guess, what is the difference? 150 minus 126 is what, 14? You would have had 14 over 126, which equals that. Okay, what are we going to do for homework tonight or classwork today? You're going to do on page 147, 1 to 6. Okay, so you're going to do 1 to 6, 9 and 10. We're not going to do 7 and 8 because they're doing the percent of error. Today we're not going to do percent of error. So 1 to 6, 9 and 10. Let's turn the page. And I would like for you to do number 11. 11, 12, and 13. And I think that'll be it for today. None of those asks for the percent of error. We're just doing percent of change. So on page 148, you'll do 11, 12, and 13. And then on page 147, you are doing 1 to 6 along with 9 and 10. I will put this into my Google Classroom so you have that information. You have 27 minutes. I think you can get this all done in 27 minutes. After that, you can do reflex or have free time. Have a good day.